Hello friends, I welcome you in lecture number 32 on higher order ordinary differential equations. In this lecture we will discuss this question on the method of variation of parameters which was asked in GTU Winter 2022 exam. Here we are asked to solve this differential equation d square y by dx square plus y equal to sin x, and this is non-homogeneous linear ODE with constant coefficients. And to apply the method of variation of parameters, we should remember or recall the formula for the particular solution, which is given by yp equal to minus y1 times y2 times r over Wronskian integral with respect to x plus y2 times y1 times r over Wronskian integral with respect to x. In this formula, this y1 and y2 are the solutions of the corresponding homogeneous differential equation, and w is the Wronskian for these two linearly independent solutions y1 and y2. R is the term on the right hand side or function on the right hand side, which is sin x here. And before starting with this method, we have to make sure that coefficient of highest order derivative in the given differential equation is 1. If it is not 1, we have to make it 1 before we apply the method of variation of parameters. Here coefficient of d square y by dx square is already 1. So this sin x will be considered as right hand side, and we start with writing this given equation. And first we have to solve the corresponding homogeneous differential equation. Given differential equation is d square y by dx square plus y equal to sin x. We give this number 1, and then we write down the corresponding homogeneous ordinary differential equation. The corresponding homogeneous, we have to consider right hand side equal to 0 to write down the corresponding homogeneous ordinary differential equation, that is d square y by dx square plus y equal to 0. And the general solution of this equation number 2 will be the complementary function of given equation which we have given number 1. To solve this equation, first we have to write down the auxiliary equation for this equation which is homogeneous, and auxiliary equation is written by replacing nth derivative by nth power of lambda and y by 1. This is second derivative, so that is replaced by lambda square, y is replaced by 1, so we have lambda square plus 1 equal to 0 as auxiliary equation. And to solve this, I am taking this 1 on right hand side, and we know that minus 1 is the square of imaginary number I, therefore lambda square is equal to I square. Therefore we have two possible values of lambda, plus or minus I, and this we can rewrite as 0 plus or minus 1 times I, and this we compare with alpha plus or minus beta I. Suppose this is equal to alpha plus or minus beta I, then we have alpha equal to 0 and beta equal to 1. And in the case of complex roots, we know the formula for the solution. It is given by c1 times e raised to alpha x cos beta x plus c2 times e raised to alpha x sin beta x. Alpha is 0, beta is 1, therefore complementary function is equal to c1 times e raised to 0x cos x plus c2 times e raised to 0x sin x. We take alpha equal to 0 and beta equal to 1, and therefore our complementary function is equal to c1 times cos x plus c2 times sin x. This right hand side is nothing but general solution of this homogeneous differential equation, and general solution of this equation is called complementary function of given equation which we have given number 1. Now we have two linearly independent functions in the complementary function, so we denote them by y1 and y2. We consider y1 equal to cos x and y2 equal to sin x. And for method of variation of parameters, we have to find out the Wronskian of these two functions. The Wronskian of y1 and y2 is by the definition w is given by 2 by 2 determinant with first row as y1 and y2, second row as first order derivatives of y1 and y2. y1 is cos x, y2 is sin x, derivative of cos x is minus sin x, and derivative of sin x is cos x. And now we evaluate this 2 by 2 determinant. We take cross multiplication, cos x into cos x, that is cos square x, minus sin x into sin x, that is minus sin square x, and this negative positive, so we have cos square x plus sin square x, and that is nothing but 1. Therefore value of Wronskian is 1 in this case. Now once we have obtained Wronskian, we have to see what is right hand side in given equation. Right hand side is sin x, so that we denote by r of x. It is a function of x, so we take rx equal to sin x. So we have all these things required in this formula: Wronskian, right hand side, y1 and y2. So finally we have to plug in all these values in that formula. So now we can find out particular integral or particular solution. The particular integral of given equation is by the formula yp equal to minus y1 times integral of y2 into right hand side function plus divided by Wronskian plus y2 outside, y1 inside the integral, right hand side function denoted by r divided by Wronskian integral with respect to x. And we are having all these values now, so we can put them in this formula. y1 is cos x, y2 is sin x, right hand side is also sin x, Wronskian is 1, plus now y2 is sin x and y1 is cos x into right hand side, which is sin x, divided by Wronskian, which is 1, integral with respect to x. Let me rewrite all these things again. So this is equal to minus cos x, here sin x into sin x, that is square of sin x, plus sin x into cos x, so that I can replace by sin 2x by 2. We know that sin 2x is equal to 2 sin x into cos x. Therefore sin x into cos x can be replaced by sin 2x divided by 2. So let me replace sin x into cos x by sin 2x divided by 2, integral with respect to x. Now to integrate this, we have to replace sin square x by that formula. We know that 2 sin square x is equal to 1 minus cosine of 2x. Therefore sin square x is 1 minus cos 2x divided by 2. So first we have to replace this sin square x by 1 minus cos 2x divided by 2, integral with respect to x. And here first I am taking this 1 by 2 outside the integral, and I will integrate in the next step. This is easy to integrate, we have ready-made formula. Therefore yp equal to, here I can take minus 1 by 2 outside, and integral of 1 minus cos 2x. Integral of 1 with respect to x is x, minus integral of cos 2x is sin 2x divided by 2, plus sin x divided by 2. Integral of sin 2x is minus cos 2x divided by 2. Now rest of the things are nothing but simplification of all these terms. We multiply this bracket by minus cos x by 2, that is minus x into cos x divided by 2. Here negative negative positive, I can write this as sin 2x into cos x divided by 2 into 2, that is 4, minus here sin x into cos 2x divided by 4. And let me further simplify if it is possible. This is minus x cos x divided by 2. Here I can take 1 by 4 common, and in the bracket I will have sin 2x cos x minus cos 2x into sin x. Now you can see some formula here. This is sin 2x into cos x minus cos 2x into sin x. If you recall this formula, sin of alpha minus beta is nothing but sin alpha cos beta minus cos alpha sin beta. So you can compare this with this right hand side, sin 2x cos x minus cos 2x sin x. So if you compare this with this right hand side, you will see that alpha is 2x and beta is x. So that I can rewrite in simpler form using this formula. I am writing this as it is minus x cos x divided by 2 plus 1 by 4 sin of alpha minus beta. Alpha is 2x, beta is x. Therefore yp equal to minus x cos x divided by 2 sin 2x minus x, that is sin x divided by 4. So this is the most simplified form for the particular integral of given equation. And once we obtain particular integral, we have to write down the general solution by taking addition of complementary function and particular integral. Y equal to CF plus particular solution, which we have denoted by YP. So let me put values of CF and YP. CF was C1 times cos x plus C2 times sin x. Particular integral is minus x cos x by 2 minus x cos x by 2 plus sin x divided by 4. Now you can see here we have sin x common in these two terms, so we can further simplify by taking sin x common. So if I take sin x common, I will have C2 plus 1 by 4 into sin x minus x times cos x divided by 2. Therefore y equal to C1 into cos x. Now this C2 is arbitrary constant, 1 by 4 is also constant. So we can see that this is going to be constant. So let's denote that constant by C2 dash. So C2 dash is arbitrary constant into sin x minus x cos x divided by 2, where this C2 dash equal to C2 plus 1 by 4 and this C1 are arbitrary constants. So this is the required solution of given differential equation using the method of variation of parameters. Now suppose method is not specified, then you can easily solve this question using shortcut methods. So for that I am explaining here using shortcut method also. Here it is specified that using the method of variation of parameters solve this equation. But suppose they don't specify the method, then instead of going for variation of parameters, you will be able to find out your solution in less number of steps as compared to this. So first we are writing the complementary function. That part is same here also, and this I have to write as d square plus 1y equal to sin x. For shortcut methods we are writing in this form, where capital D denotes d by dx. Complementary function is already obtained, so that I am writing here c1 cos x plus c2 sin x, and I am finding particular integral using shortcut method. So here from this y will be equal to 1 over d square plus 1 times sin x, and we know that if we have sin x or cos x as our right hand side, in shortcut methods we are replacing d square by negative of alpha square, where alpha is the coefficient of x in sin x or cos x. Here alpha is 1. If we compare with sin alpha x and this function, then alpha is 1. Now if I take alpha equal to 1, I have to replace d square by minus 1 here, but that will make this function 0. If I put d square equal to minus 1, I will get 0 here. So what we are doing in that case? In that case we differentiate this function with respect to d and we multiply by x. So here I am multiplying by x because I am differentiating this with respect to d, and derivative of d square plus 1 with respect to d is 2 times d into sin x, and we know that this 1 by d stands for integral, d stands for derivative with respect to x, and 1 by t stands for integral with respect to x. So I have to integrate sin x with respect to x, and integral of sin x is minus cos x. Therefore we have minus x cos x by 2 as our particular integral. Now you can compare, we have obtained this same particular solution here, minus x cos x by 2. So you can see here, you can compare both the methods. This is using shortcut methods. We are able to decide the particular solution within 1 or half minute. We have to simply replace d square by minus alpha square, and if f of d becomes 0, we have to differentiate with respect to d, and the number of times we are differentiating we have to multiply by that power of x. Here we are differentiating single time, therefore we are multiplying by x, and we have yp equal to minus x cos x by 2. So be careful, if your method is specified, if they specify that solve your differential equation using method of variation of parameters, then you must solve using specified method. But if method is not specified, then you can go with shortcut methods and you will be able to find out the solution in less number of steps and in less time. So this is all about this session. We will continue with GTU exam questions in upcoming lectures. Thanks for watching.